Hey, Rakshazak, Rockaduck, did Mr. Spock. um, and Steph. Okay, it's less than 12 time. That's a 1 there. 12. 8, 4, 0, 0. Properties of real numbers. We're still on real numbers. Man, real numbers are just like the building blocks of lots and lots of math that we do, and they're the most readily available numbers thus far, right? Okay, we've been using them. You've been using them for many, many years. Hello, have a hang on. Text from wife. Okay, gotta take care of. Yes, we have half and half. Let me know. Real numbers? They say something about that? Yes. Properties of real numbers? Yes, let's go. Okay, so we're going to lay some things out. I'm going to give it to you like symbol-wise and talk a little bit about why, okay? I kind of like knowing why and having these things in my head because you'll ask questions and say, well, why do we do that? And I'll be like, well, remember the identity property, remember the associative property. And I want to try to help you remember which thing is which too. So you're going to need your notebook. And some of these things are already listed on your Algebra properties reference sheet, though they might be in a different format than what we're going to talk about today. But what we're going to be talking about today can be found in the upper left corner here. You got the words associative, commutative, distributive, though I don't think we're talking about distributive property, just associative, commutative, and identity. Identity. But they are there. And but I'll try to explain those a little bit for you today. Okay, make yourself a grid like this and give yourself a little bit of space to put in property, maybe a property and an example. I kind of like this better than what they do in the book, so I guess you can pick what you prefer there. Lesson 12. Okay, here we go. Both for addition and multiplication, there is the, oh gosh, I guess in the last video I called it the do nothing property. There are lots of these throughout math and lots of different kinds of systems and types of problems that you're doing. You have to have something that brings you, it doesn't go anywhere. It's like the origin in graphing. You have to have that reference point there for starters. Okay, so what is that? Well, identity is just who you are, right? You can identify that is its definition. And so with real numbers, the identity property for addition goes like this. You take a number, A, and you add nothing to it, and what do you got? You got A. So that seems kind of silly, but there we are. We're using addition, and we're doing nothing, and we have what we are. So there it is. A is A. With addition, if you add 0 to A, you still have that number. With multiplication, we can't do 0. We just talked about that, how it makes everything 0. We don't want it to disappear. We want the thing to stay there. So if we take A and multiply it by 1, we still have A. That is the identity property for multiplication. Okay, both of those we have to have. We have to have in order to do math and to be honest about what we're doing. The other two are hard to keep track of which one is which. And give you a little thing here. Let's say that that you live in Chico, but you go to school in Orland. All right, you have to commute. Okay, every day you have to commute. And so here's your home. Your home will be A, and here's school. That'll be B. And what you do in the morning is you go from home to school, and then hopefully in the afternoon you go from school back home, unless you are going to sleep here on campus. Okay? And the commutative property says, you know what, if we're counting up how far that is, it honestly doesn't matter which way you go. It should be the same distance from home to school as it is from school to home, right? So it's about like just direction. Which way am I going? But that really doesn't matter. I can go either way and I'm doing the exact same thing. I'm going the same exact distance, I suppose. So what does that look like for addition? If you go A and B, that's going to be the same math as B and A. When it comes down to numbers, it means that you can add things in any order that you want to, which is really nice. If you get those big long lists like this, and they say go ahead and add those things, you don't have to add it from top to bottom or from bottom to top. You can add these things in any direction that you want to. And I prefer to look for things that add up to 10 as much as possible. Do those first because those are the easy ones. So I just start here and I go, well, 3 and 7 is 10, and 2, and I'm going to skip down here to 8, that's 10, and 6 and 4 is 10, and do it that way. That allows me to add these things in any order that I want to, and I know I'm still going to get the same answer. Do it on a number line, right? You go A, and then you go distance B, or you go distance B, and then you go distance A, and you've done the same exact thing. You've got to the same distance away from the origin. What does that look like for multiplication, you ask? Well, very similar. Remember your multiplication tables and doing those cards? And when is it that you finally realized that 8 times 6 was the same answer as 6 times 8, right? Are you doing those grids where you're filling in your multiplication tables really fast, and you had a 6 and an 8, and then you're just kind of like, oh, 8 times 2 is the same thing as 2 times 8. I already know that one. And so you don't have to memorize all of them. Some of them you just say, well, I already know that because I've seen it in the reverse order. With numbers then, that's A times B is the same thing as B times A. And if you'd like to, you can throw in A and B and C and D if you want to, and it will still work, right? Like I did that list of numbers. If you got multiplication, let's say that you're doing 2 times 5 times 3 times 2 for whatever reason. You can take any two of those numbers and multiply them together first before you do the. I look at this and I see 15 times 4. Or I see 6 times 10. Or I see 6 times 10 again. Yeah. Or I see 3 times 2 times 2 is 12, and 12 times 5. So there's all those different ways to do that. That's commutative. I can do it in any order that I want to. Okay, commutative has to do with order. Associative has to do with grouping things. You know, people that have work, they have an associate that they work with. And associative works like this. We're not going to change the order, but we're going to have 3 things. Oops, addition. Associative says that I can take this and I can group A and B and get a sum there before I add it to C. Or I can go ahead and have A and add that to the sum B plus C. So associative is about grouping, and commutative is about order. Okay? This is about grouping. I keep the order the same in associative and group them differently. I'm allowed to do that. So if I had 3 plus 5 plus 2, I could say I'm going to sum that up before adding 2. Or I can take this 3 and add it to the sum 5 plus 2. 8 plus 2 is the same thing as 3 plus 7. Okay? Associative. And very similar with multiplication. A times B times C equals, I can multiply those two together first and then multiply by C, or I can take A and I can multiply that by B times C. That both of those they're all the same thing. So again, if I got 5 times 2 times 3, I can have 5 times 2 times 3, or I can have 5 times 2 times 3. Again, it's the way that we group things, not the way that we order. The order stays the same, but the grouping changes. Okay, there's all of our properties. They're going to ask you then to say which property they're using in a particular case. In example 1, They're just going to throw in real numbers, okay? They're not going to have A's and B's. They're going to do things like I did, where they're going to have real numbers. They're going to do something with it, and they're going to say, what property did I use? Right. The thing for you is, I mean, you're going to have to know what's going on here because we're going to layer on top of this thing as we go along. But we want these to be tools in your hands. Sometimes you'll look at a problem and say, what can I do with that? And you can say, well, these are the rules that we get to play with. You can use the commutative property and reorder the thing if that makes the problem easier to deal with. Or associative, I'm going to group these things together first. This even kind of lends itself to factoring, right? I can pull something out from the rest of the things and treat it separately because the associative property for addition and multiplication is true. A second thing you're going to do with this is that you're going to have to learn how to justify the steps you take to get the right answer. You have to know what you're doing and why. Okay? I mean, your parents ever come say, why are you doing that? And you go, I don't know. And they say, why not? And you say, I don't know. And now if you're doing it, you're like, I'm just using the associative rule. And they'd be like, what? And they're like, you don't know the associative rule? That's what makes the world tick, people. So examples 2 and 3, you're justifying the steps to simplify. You're using properties to justify. You're saying, I'm using this property, and then I use this property, and I got this answer, and aren't I a smart person? Okay? You're going to start using these properties. Make sure you've got them written down with some examples. You should be ready to go on that. You're going to want to refer to these often until you have them memorized, that you can say order. Changing order is commutative. Going from here to there is the same thing as going from there to here. Both addition and multiplication. Associative is the way that we group things, but we keep the order the same. And identity has zeros and ones in there. 0 for addition and a 1 in there for multiplication. But again, identity is the do-nothing property. Okay? We're going to need those as we go into more and more math. Hope that helps. Makes a little bit more sense. I'm done talking. Goodbye, good evening, and farewell.